Assalamu alaikum. We'll be continuing with our lectures of organic chemistry. But before continuing with our lectures, I guess today's class will be mostly solving our examples as well. I guess we won't be able to cover more part of like today. I guess our entire class will be devoted to doing some examples. These examples are like pretty much for helping of like these are going to be helping you in order to like remember or recall those like formula for the general formulas, the structures and the conditions, because there are, like as we have seen so far, like there are a lot of conditions. So I guess this will be like helpful for you. So okay, so let's start with our examples today. Let's say we have been given this molecule, which is a benzene structure with sort of some side chains. The condition is given here, let's say Cl2 with UV. Sometimes it will be plus UV, it will be given, or sometimes comma UV. That means the same thing. Some product will be formed here, which you need to find out. From here, we will be provided with sodium hydroxide in aqueous condition, and will be given heat under reflux, or simply reflux. Reflux simply means heat under reflux. Okay, so in short, they tend to write heat under reflux. From there, we'll be getting some other product. So this is our this first part of the example. In the same question, they are given the same molecule. Initially, we have the same molecule. From there, they are providing us with Cl2 with AlCl3 and hydrous, and we would get some product here, which we need to find. And from there, when we further add HNO3, and in that H2SO4 at 55 degrees centigrade, we should get some other product, which we also need to find out. Finally, we have the same initial starting molecule, and the conditions are given in this case, KMnO4. With that, we have been given OH minus with heat, then H plus. We would get some product here due to the reaction. And from that product, when we further make it to react with CH3OH with concentrated sulfuric acid, concentrated H2SO4, concentrated sulfuric acid, and heat is applied, we would get some product here. Okay. Now, the formula here they have given only for this one is C6. What is given? C. C10, isn't it? C10 H10 O4. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Isn't it? Yes, I guess. Okay, yeah. So now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Okay. So now let's start from the beginning. Now I would urge you to pause the video here and try it by yourself, because it doesn't matter if you get it or not. Understanding the condition and understanding like what type of reaction it is, and like recognizing what is the reaction happening, that's more crucial than being able to answer. Okay, it doesn't matter like if you are able to answer right now or not, but it's more important for you to understand, okay, what type of reaction is this, what type of reaction is happening here. Okay, seeing the reaction like the conditions. Okay, now let's solve it together. So over here, as we can see, it is what? Cl2 plus UV. That means we can clearly see it is actually free radical substitution, which is a reaction for alkane. So that means this is not going to actually participate for the benzene part. Rather, where is it going to participate? It is going to participate to the side chains. So either of the side chain would work here. Okay. Now, since so far they haven't given us like much information, we would consider here one chlorine molecule. So that chlorine molecule would give us, let's say this will stay here and this will give us a simple Cl. Okay, so this will be our product in this case. Why? Because like we would have done the same thing over here. Like if let's say they haven't told us, we would have done the same thing over here. But for the sake that they have given us, let's consider 1 mole of chlorine. Okay, like even if you have given here also chlorine, that would have been completely perfect, no issues there. So in this case, let's give a criteria that they have mentioned here, that the structure should be C6H, sorry, not C6, it should be C8H 4, 5, 6, 7, 8, 9, 10. Okay, let's say this is the structure they have given us, provided us with. Okay, that means let's consider in this case also we have given chlorine here. Okay, because free radical substitution means what? All the alkanes are going to undergo free radical substitution. Here is the alkyl group, here is the alkyl group, which actually represents sort of the alkanes part, yeah, which resembles actually the similarity of alkane. Now, when we have, let's say, like further we are adding sodium hydroxide aqueous with reflux. Now, what type of reaction is this? This is the reaction for what? For like here we have actually halogen alkanes, isn't it? We have halogen alkanes here. Let's forget about the benzene now, right at this moment, because benzene does not react with sodium hydroxide, like in such cases. So we have halogen alkanes here, and sodium hydroxide, when it is added, that means what? It is actually undergoing nucleophilic substitution reaction, isn't it? Let me cross check. Yes, it is a nucleophilic substitution reaction. So this was free radical. This is nucleophilic substitution. Remember, I asked you to write the reactions beside, so that like it helps you to recall actually what type of reaction it is. So I will like, so for while practicing, always write the type of reactions beside, because it will help you to active recall, and at the same time while solving questions you would be like revising the notes as well. Okay, so this will be very helpful. Substitution. Even if I don't write it by yourself. So nucleophilic substitution reaction is happening here. That means what? These halogens are going to be replaced by our sodium hydroxide. That means we'll be left with what? By replacing chlorine or substituting chlorine, we would get OH. But see, here we have what? Only one oxygen. That means there was, in the free radical substitutions part, only one of the chlorine actually substituted. Okay, that's why I was showing that, like, since they haven't mentioned as much of a thing, we'd consider only one of the chlorine. And over here also, since like the other things remains identical, Now, like such should be the condition, or you could give the same OH group on the other side as well, but only one should be present there. Now let's count if the formula, like molecular formula and the structure matches. So we have 1, 2, 3, 4, 5, 6, 7, and 8 carbons. So we have 8 carbons. Then we have 10 hydrogens. So one hydrogen here, one hydrogen here, one hydrogen here. Let me do it circles. 1, 2, 3, 4 hydrogens here, 5 hydrogen here. And from this carbon, we have 2 more hydrogens. So that means 1, 2, 3, 4, 5, 6. And over here we have 3 more hydrogen, 7, 8, 9. Wait, so should it be H10 or H9? I gave you just for an assumption, like by myself. 1, 2, 3, 4. And then we have 5, 6, 7, 8, 9, 10. Oh, okay, it's it's 10 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, it is 10 actually. 3, 4, 5, 6, 7. Yeah, it is 10. Okay, so we have 10 hydrogens here and 1 oxygen. So that means it matches the criteria. Now let's move to the next one, where we have given Cl2, Cl3 in anhydrous condition. Whatever reaction is it, we can understand it is actually a electrophilic substitution, which is the reaction for benzene, isn't it? It is electrophilic substitution, and to be more specific, in this condition, it is actually the Friedel-Crafts alkylation. It is not actually Friedel-Crafts alkylation because we haven't been given alkali here, but the condition is actually based on Friedel-Crafts alkylation. Okay, so the conditions are for what? The Friedel-Crafts alkylations condition, because this is the condition for Friedel-Crafts. Friedel-Crafts, yeah, Friedel-Crafts like condition. But since no alkali is present, so like we can still consider it as like Friedel-Crafts. The reaction is for Friedel-Crafts, like the conditions are for Friedel-Crafts, but the alkali is not given. So like it is not alkylation reaction. Simply chlorine is going to like replace the hydrogens here. Now this is electrophilic substitution, electrophilic substitution. Okay, now chlorine is going to replace like any of the like hydrogen from the remaining carbon atom. Like let's consider this as the 1 number carbon, then we have what, 2 and 4 number carbons, like where reaction can happen. Also 6 can happen, but already 6 we have what, an alkyl group, and alkyl groups are much more stable than chlorines. Okay, that's why like this carbon won't be replaced, or this hydrogen, like this bond with the carbon, like this part of this carbon won't be replaced. Only those which have hydrogens with them. This carbon and this carbon has hydrogens with them. Okay, so that means only they can be replaced. Now drawing the structure, that means like any one of them would work here. So this is the condition, like the structure, and we have Cl here. Okay, so we have this chlorine. Now when we add nitric acid in concentrated, like in like nitric acid in called sulfuric acid at 55 degrees centigrade, what type of reaction was this? Remember, in notes we have given concentrated nitric and concentrated sulfuric acid, but they gave here like they didn't mention concentrated. It's completely fine. While you are writing in your like exam, if they ask you to write it in the exam, write it concentrated. Okay, so this is actually what this is, formation, like this is actually nitration of benzene, isn't it? Nitration of benzene. Okay, so nitration of benzene is happening. That means where is nitration of benzene going to happen? In one of the like free hand, in one of the free hand. So nitration of benzene in this case, remember like always that nitration of benzene is going to happen from the odd number of carbons. Like if let's say, or where we have, let's say this is the this is the initial condition. Now the nitrogen, like the carbon which will be just after the first bond, like this bond over here, we have this bond, isn't it? So after the bond here, there will be our nitrogen, because we tend to like count in which way? We take like count like the carbon like which one of the carbon are we supposed to take as the number one carbon, the number two carbon? In this case, what did we do? In this case, we actually say this is carbon number one, this is carbon number two, isn't it? That was because initially the bond was over here. Okay, so if we count always rightwise, I mean the clockwise direction, that means what? We should consider this as one, this as two. Now, since we already have a bond here, that means that should be our number of carbon, because we need to see just after that where is the like empty bond, like where is an empty space or hydrogen is present. Over here we have a hydrogen, imaginary hydrogen, isn't it? So that means now we should consider this carbon as number, like the carbon number one. Why? Because we need to see which one of the carbon atom has an adjacent carbon atom which has only hydrogen with it. So this is the adjacent carbon and it has the hydrogen with it, and we are like counting in which direction? Clockwise direction, isn't it? So that's the case. That's why our like the second carbon atom is in this case over here, and this is our nitration of benzene happening. Okay, I hope you got it. So in the next part, we have KMnO4 OH minus, then said heat, then H plus. What does this mean actually? This is meaning we are actually giving, like this is an oxidizing agent in like alkaline condition. Okay, we have what we can oxidize either in like in acidic condition or in alkaline condition. Now after this alkaline oxidation happened, then it said heat was applied, then H plus. Okay, so that means like we can also say it in this way, that KMnO4 OH minus heat was applied, then H plus was added to the resulting solution. That means the product we found from this, like from adding this, on that product we applied H plus. Okay, that's what it means. Like why is it like so? What's the reason? The reason is, at first let's do this. For benzene, where oxidation happens to the side chains, all the side chains becomes what? Carboxylic acid. But what happens for acidic and alkaline hydrolysis? For acidic hydrolysis, this becomes carboxylic acid. Okay, this should become carboxylic acid. But for alkaline hydrolysis, this should become the salt of the carboxylic acid. That means COO minus and COO minus. Okay, and let's say, since in this case, let's say like if this like this hydroxide was like, if we would have gotten it from, let's say, sodium hydroxide, then here it should like there should be Na, that means salt of this like carboxylic acid with respect to like sodium. Then when we add H plus, that is that means we're actually making this sodium to like replaced by H plus. That means there will be no more sodium here, or the sodium or the Na plus will be replaced by our hydrogen. That means we'll be left with COOH and here COOH. That means the same thing is happening, isn't it? So that's what actually like they tried to mean, that like giving like either way, if you directly apply acidic like oxidation is happening, or at first alkaline oxidation is happening, then acid is being added. In both the situation, like same thing happens. Okay, so it's like the same thing is like over here, like the acid will be forming in this case. Okay, but if H plus was not added, then only the salt would have been present here. Okay, now let's see what are they saying as for the next part. They're saying we have given this reagent. Now what is this reagent? We can see clearly this is actually an alcohol. Now they are making this alcohol to react with this structure in presence of concentrated sulfuric acid and heat. Now remember, what type of reaction is this? This was actually oxidation for such side chain. Okay, side chains. Now, what is this? Try to recall. This is very like early topics. This is actually esterification. Now, based on these structures, okay, based on these formulas, this could be like actually found. Why or how? See, the oxygen number is 4. That means the oxygen number didn't change. and carbon numbers are also carbon number changed. Now, how this carbon number changed? Over here we have 8 carbons, and over here we have 10 carbons in the molecule. That means the only possibility is that like 2 of this CH3 is going to get added over here. If like, how do I know? Because we have 8 here, and only if only one of them is added, that means only like we have 9 carbon in that case. But they're saying we should have 10 carbons. That means only this is the condition, and that is one of the that is only reaction where we can get actually like 10 carbons. So this should be C double bond O, and here we should have CH3, and here we have C double bond O, CH3. Okay, now let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon, 4 oxygen, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So we got our answer. Okay, now let's do, or let's go to the next example. Let's say we have been given this molecule where it is anything given here? No, there's nothing given. So direct benzene is given. We are adding here, let's say, concentrated HNO3, H2SO4, 55 degrees centigrade. We should get a product here. On that product, when we add SN plus concentrated HCl and some heat, we should get a product here. From there, when we add, let's say, yeah, Cl2 with FeCl3. And hydrous. We should get this product, okay? Now, based on the situation, try to solve it. Solve it by yourself, okay? Try to solve it by yourself. If you can't, we will be doing it together. Nothing to worry about. Okay, so here, what is happening at first? This is a benzene ring, and we can see this is actually the condition for nitration of benzene here, isn't it? And we can take the help from one of the product being given here, which is the amine group is over here. And we can see this reaction is what? After nitration of benzene, in this step, what do we do? This is actually formation of phenylamine, isn't it? So phenylamine, and we have a phenylamine group here. That means the nitration of benzene should be on the first carbon or the topmost carbon. That means nitrogen should be here. This is what electrophilic substitution reaction. Now this is nitration of benzene, and over here we were having formation of phenylamine from the nitration of benzene. That means NH2 should be here. Okay, so first so good. Now see one thing, this condition here, like after adding this, we get chlorine. But see, in the previous example and in this example, we have one thing in common, which is our chlorine part. See over here, this chlorine, which was given here, and the chlorine which we have been given here are the same, isn't it? Chlorines are same, but condition, let's see. Here we have FeCl3 anhydrous, and over there we have what? AlCl3 anhydrous. See the difference? So here we have AlCl3 anhydrous, and here we have FeCl3. What's the difference? The difference is AlCl3, remember, I have like mentioned today also, AlCl3 is for Friedel-Crafts. Friedel-Crafts, okay. Maybe my spelling is mistaken, whatever it is, but it is the condition for Friedel-Crafts, okay. That's basically condition for Friedel-Crafts, and this is just like normal reaction, like this doesn't have any name, okay. Let's move on to our next example. So we have given here, let's say, this is the product from our previous example. Let's say this one. So over here, from there, let's say we are making few reactions in this case. Let's say in one of the reaction we are adding Br2 aqueous. In another reaction we are adding, let's say, OH minus. And another reaction we are adding, let's say, NaNO2 with HCl. Okay. And in another reaction we are adding, let's say, CH3COCl. Okay. So we need to find the reaction now. Pause the video, try it yourself. If you can't, it's completely fine. Let's see. So in our first reaction, what we can observe is here we have a phenylamine with bromine. We know identification of phenylamine is done through bromine reaction, isn't it? So what happens in that case? The carbons in the second, fourth, and sixth number carbon, they tend to react. But since our fourth number chlorine is already filled, so that is not going to react, but rather our only second and sixth number carbon is going to react, forming what? Br, and we have chlorine here. Okay, so that is our reaction. So in this case, it will be forming a white precipitate, isn't it? White PBT. Okay, now when hydroxide is added, what happens? Hydroxide is what? Alkaline solution. And phenylamine, since we have an amine group, that's also an alkaline solution. That means no reaction is actually going to take place. Okay. But remember, phenol is acidic. So phenol was supposed to react, but phenylamine is not going to react. Now over here, with this phenylamine, when NaNO2 plus HCl adds, what happens? This is actually what type of reaction? Remember, benzene diazonium chloride is being formed. So this is the benzene diazonium ion, where we have N with triple bonded with another N. Remember, this is our condition. This chlorine will remain this chlorine. With that, what will be like coming? The thing which is going to get like coming here is the chlorine ion here. If like since HCl is added, this Cl is going to come here. If like instead of Cl, let's say sulfate was added or some other like acid was added, and that anion would have come here. Okay, since in this case chlorine is added, so that means we should get what like the benzene diazonium chloride in this case. This is the benzene diazonium ion, and we have this chloride ion. Okay, now in the last reaction, what we have CH3COCl, that should give us what? This is actually what type of reaction is happening. This is an acyl chloride, isn't it? Acyl chloride is sort of acidic, we can say, or acts as an acid. And we have what here? Phenylamine. And we know amine groups react with CH3COCl. We have already studied in the previous or the lecture before the previous, like the lecture before the previous class. There we have learned that amides are formed when carboxylic acid reacts with amine, or when acyl chloride reacts with amine, they also tend to form the amides, isn't it? So in this case also our amides will be formed. Here we have a Cl, and here we have N, H, and C, O, and we have here CH3. Okay, so this is the bond being formed. So from here one of the hydrogen will be like eliminating, and from here one of the fluorine will be eliminating, leaving us with this amide, like this amide linkage. Okay, amide linkage is what? This is the amide linkage. Okay, this is the amide linkage. Now let's move on to our next example. Let's say we have been given here a CH3 molecule. We are adding with it Br2 and AlCl3. Now when this is reacted, this is a product we are getting. From there, when we add, the first condition is KMnO4 plus OH minus, and in the next step, like two-step reaction. So in the first step, we're doing this. Second step, we're adding H plus, okay? This is one of the reaction happening, and we are getting, in this case, the final product is this one, COOH and Br, okay? And over here, we are adding in the first KMnO4 plus OH minus, and the second condition, we're adding H plus. What should we get here? That's what we need to find. And from there, we should be adding something. In this case, let's say HNO3 and H2SO4. So what should we get here? Try to do it. Wait, we have one more thing left here. From here, if we add further, let's say, further, let's say SN plus concentrated HCl. And with that, let's say in the second condition, we had OH minus. So what is going to happen here? Do it by yourself, or pause the video, try it by yourself. We'll be doing it now. So over here, we can see this is what? This is actually electrophilic substitution reaction. Benzene's reaction is going to take place, and we have bromine here and the Friedel-Crafts condition. Anhydrous, they haven't written, but when you write, do write anhydrous. So this is actually going to take place where? See, bromine is in this place. That means there is the bromine going to get added. CH3 remains. Bromine is going to be here. And see over here what we have. We have KMnO4, so H minus, then H plus. That means here we have an oxidation reaction. Remember, OH minus, that means alkaline oxidation. So first salt of the carboxylic acid is formed, then H plus is added. That means carboxylic acid is then regenerated. So this is our product. However, in the reaction in the bottom place, towards the bottom, what is happening? What should be happening here? Again, a carboxylic oxidation reaction. That means first salt of the carboxylic acid, then carboxylic acid. So we will be having here our carboxylic acid initially. Okay, now over here, when we are adding HNO3 and sulfuric acid, what is going to form? This is what type of reaction? This is actually nitration of benzene, isn't it? They haven't provided here, let's say, any temperature, 55 degrees centigrade, but still this is nitration of benzene. So oftentimes they will tend to give this sort of reaction, like they are going to write conditions which will be not exactly similar, but you will get the thing, yes, this is actually nitration of benzene without the temperature being provided, but still some sort of reaction will happen here. So that means we are going to get a nitration of benzene is going to happen here, but how? Now, in nitration of benzene, what happens if our first carbon is filled up, then we cannot come to our second carbon, rather we'll be coming to the third carbon. So in this case, third and fifth carbon gets active, okay? Now these carbons are deactivated. Only the third and fifth carbons are activated now in this case. So we'll be having here our NO2. Now after this, when we add further this one, like T in concentrated hydrochloric acid, what is going to form? We're going to get our at first let me draw it here. The first condition is stated what? HCl, isn't it? That means this is going to form amine, phenylamine. Now let's see, OH minus is formed. What is going to happen here? OH minus is not going to react because both are alkaline, but think this way. This is a carboxylic acid. That means what? They are going to react. That means what will be left with? This is going to actually form what? COO minus. Okay, so that's what is going to form here. In the first condition, what is forming? Let's see. In the first condition, we are getting here COOH and what? With our benzene here. Okay, this is the first condition given here. Okay, In the second condition, they are saying hydroxide is added. Now, hydroxide doesn't react with like phenylamine, but hydroxide does react with like acid, because this is alkaline and this is an alkaline, so like this is an acidic solution, like this is acidic. That means they are going to react to form what? COO, like hydrogen is going to go from here. That means this is going to be left over and we'll be having NH2, isn't it? Because water will be formed as a byproduct. This is a neutralization reaction, isn't it? So the overall reaction is which one? This one. So this is the final product. Okay. So that's what I wrote. Now, the other example we are having. Okay. So let's see. This is our, I guess I have to do a second part of this video because I'll be having like I have to pause the video over here. Okay. So we'll be having our next two examples in the second part of the video.